Good morning. I'm here today. Well, actually, I'm not here today. I'm coming to you pre recorded from Seattle, Washington, because the UK time zone is a little bit further ahead of those of us in Seattle. So we decided to go ahead and do this as a pre recording so that you don't have to see what I look like at 3 in the morning, because trust me, that is not a pretty sight. What we're here to do today is talk a little bit about Python for Java developers. The title of this is The Busy Java Developer's Guide to Python. And what I want to do with this is I want to talk fundamentally about a couple of things. Number one, I want to introduce you to the Python language. It's an interesting language. It's a very popular language, particularly amongst the numeric and scientific crowd. Because of that, it gained a lot of popularity in the data science world. And so in many respects, knowing the language is a very, very useful tool to have in your tool belt. We're also going to talk a little bit about how Python integrates with the Java ecosystem. And predominantly, that's going to be Jython, which is a Python implementation written in Java. It's been around for quite some time, as well as GraalVM. Graal is a new project from Oracle Labs, been around for a couple of years now, provides a sort of universal runtime for a lot of different languages, including Python. So we'll talk about how both of those can interact with the world. We'll get into some of the basic Python stuff, talking about types. We'll go over flow control, some of the Python syntax around that, talk about functions and classes, and we'll touch just very briefly on metaprogramming. Key thing to understand here is I'm not going to try to teach you the entirety of the Python language in a 50-minute time frame. It's not possible. There are a number of books out there. There's a number of resources. I'll show you the Python tutorial, which is a great resource in of itself. My goal here in many respects is to get you dangerous with Python, teach you just enough Python that you can understand what's going on, and from there continue your own journey down whatever path you care to use. Whether it's embedding Python code as a part of a Java application, whether it's calling out to Java code from within a Python application, or some other kind of integration, one of the great, powerful things about the Java ecosystem for many, many years has been the fact that it really is a multilingual ecosystem. Obviously, we've seen Groovy and Scala and so forth. Jython is another tool to have on the tool belt. And so, it's a useful thing to know. If none of that sounds interesting to you, well, hey, mate, this is Devox UK. There is something equally exciting going on next door, figuratively speaking. So don't stick around and watch me talk about something that you're not interested in. So let's get started. First things first, what is Python? Well, whenever you're not quite sure what a thing is, it's always good to do a web search. Welcome to python.org. And Python is a programming language that lets you work quickly and integrate systems more effectively. That is not a particularly useful definition. It's a nice marketing scheme, but it's not a particularly useful definition. Now, as part of this, obviously, we have discovered the python.org website. And this is a very, very well done website. There is a tremendous amount of information here. There's a tremendous amount of resources, descriptions, etc. But for the beginning Python developer, the better place to go frequently is the Python tutorial. docs.python.org/3tutorial. This is the home of the Python tutorial, and this is very much a step-by-step walkthrough of the original Python implementation. Now, it is important that I point something out. You see up here, 3.10.0. That is the current implementation of what we call C Python. There are a number of different Python interpreters in the world. We'll be talking about another one in a few minutes called Jython. The C Python current version is 3.10. Now, if you notice down here at the bottom of this drop down, there's also a 2.7. This is because a number of years ago, the benevolent dictator for life of Python, Guido van Rossum, decided that there were a number of things integral inside the Python interpreter that he wanted to change in order to make it easier to do certain features that they wanted to introduce into the language. And this is probably about 10 years ago at this point. So they officially broke away from the 2.x stream of Python and moved over to the 3.x stream of Python. Now, there are some incompatibilities between Python 2 and Python 3. And so when you dive into the Python world, you may discover certain libraries will only run with Python 2. For the most part, any new greenfield development should be done against Python 3. But there are some cases where you may have to drop back to Python 2. And as a result, there may occasionally be some incompatibilities across Python interpreters. If you are, for example, working with a Python 2 interpreter and you're trying to run Python 3 code, 95% of the Python code in the world will run flawlessly in either one. But be aware that there is a difference, and you do want to be sensitive to the idea that that could potentially down the road create some issues. In many respects, what it really has turned out to be is kind of the difference between Java 1.5 and Java 1.4, when Java 5 introduced the new syntax, the new keywords, etc. For the most part, everybody just kind of rolled with it. But there are still a few Java 1.4 libraries out there that won't run under 5, and definitely vice versa. So keep that in mind. Now, the Python tutorial here points out a couple of things. Easy to learn. Yeah, there's a lot of beginners out there who are learning Python. That's where they get that. A lot of this comes from some of the Python syntax. There's not as many symbolic things. There's some more convention things. Biggest one of these is significant whitespace indentation instead of curly brackets. Powerful, yeah. I mean, any general purpose language is powerful. Efficient, high-level data structures, simple but effective approach to object-oriented programming. This is the part that's going to throw a lot of the Java developers of the world for a tailspin, because Python is a dynamic language. It's not untyped, as is frequently argued. And frankly, untyped languages, they can perform just as well as typed ones. So don't be dismissing Python because you don't think it'll handle whatever load you want to throw at it. It most definitely will. But the key thing is that Python, being a dynamic language, we don't actually have classes in the same way that we think of Java classes. Everything is an object available at runtime, which opens up a tremendous amount of interesting power, which we'll see when we get into the metaprogramming parts of things. This is the part that's going to be the most interesting, particularly the Java developers who've ever wondered if there were ways to make reflection do more, or if you're ever interested in doing any sort of meta-object monkey patching, like they say in Ruby and JavaScript. Elegant syntax, dynamic typing, interpreted nature. Again, don't let this throw you off. What most Python interpreters do is they actually take the source, compile it to a bytecode, and then JIT compile the bytecode. So in many respects, it's almost like Java-C and Java have merged into one step. Ideal language for scripting, very useful for doing maintenance, automation on your machines, rapid application development in many areas on most platforms. And it is definitely a portable platform in much the same way that Java is and was. Definitely again, that's part of what makes it useful for that scripting capabilities, because Python also has some nice integration with underlying operating systems. There are some libraries that come out of the box that allow you to do various things. For example, on a Windows platform, you have access to some of the COM and DDE style APIs. You also have the ability to integrate with a variety of other platforms, call into a number of things. There's wrappers for everything. So a very, very extensive ecosystem. Now, what is Jython? What is Graal? Well, let's head over to the Jython GitHub. Again, open source. Both Python and Jython are done entirely open source. Extensive. It's been around for quite a while. You can see some commits from 7 years ago. If we look at the Jython homepage here, Java implementation of Python, source code under said license, blah, blah, blah. If you want to get started with Jython, frankly, one of the best ways I find is to use one of the existing package managers. So, for example, you could do a brew install Jython if you're using Homebrew on a Mac, or if you're using Homebrew on the Windows subsystem for Linux, WSL, particularly as part of Windows 11, very, very powerful. Homebrew has a port that runs on top of WSL for Windows. The other thing is there is a tool out there called SDKman. Let me bring that up here in a web page. This is a very Java ecosystem specific SDK manager. So SDK as a command line tool will let you install a variety of different JVM based tools, including Java. And again, paste this into a terminal and you now have SDK up and running on your machine. And like Homebrew, you can do a brew update, brew upgrade. You can do an SDK update, upgrade. As a matter of fact, let's see how many different implementations of Java I currently have on this particular machine. You can see here it lists, I've got the Adopt OpenJDK, I've got the 16, 11, and 8 versions installed, and it's aware of a number of different ones. Currently, I also have Graal installed, which means that if I were to actually do a Java-version, you can see that what comes up is the GraalVM implementation of the JDK. So we've got a number of different ways to run this accessible to us from SDKman. Now, SDKman can install Jython. As a matter of fact, let's see. SDKs should be listed here. I'm not seeing it. Okay, well, I'm not going to go hunting for it. Variety of different ways. Of course, in some ways, the easiest ways to grab this is to go to jython.org, grab the installer. It's a graphical installer. You can also declare it as a dependency in your Maven or Gradle build. But notice right here, this is one of the biggest downsides to Jython is the fact that it currently is only officially supporting Python 2, specifically the latest version of Python 2, 2.7. Now, again, most of the time won't make a difference. For particular purposes, for particular scenarios that requires Python 3, you may need to install Python 3. You may not be able to use Jython, in which case Graal may be a better choice for you, particularly because it does come out of the box with support for Python. And as a matter of fact, if we go to, let's see, what am I trying to do here? Library. This is where Graal by nature, well, actually, hang on. Yep, it's, well, rather than dig through. When you install Graal, generally it will create a series of binaries on your machine that will include the Python binaries. You can actually install them on demand as you wish using the GU tool in Graal. And you'll notice that they've clocked it. Now, all benchmarks should be treated with a degree of skepticism, but they've clocked it as running faster than CPython and faster than Jython. And Graal also has an interoperability capability through what they call their Polyglot API, the Truffle library, to execute and run Python code as a part of a Java application and vice versa. So both of these interpreters / ecosystems tools will give you the ability to run Python together with Java. And so, again, Jython is the more well-known one. It's been around, like I said, for about a decade or more. And most people will cite it. But, if you want, let's quickly look at embedding Java code as a part, or embedding Python code as a part of a Java application. This is a standard Gradle build that I've got here containing an application. Notice we reference two classes, PyObject and Python interpreter. And this is basically straight off of the homepage from Jython here, right? Just running it inside of code here. We execute the Python interpreter, and we'll talk about, again, syntax here in a second. We can also harvest these results. We get an object back, etc. And if we were to run this, Gradle thinks, it runs, and notice we see hello Python world in the result 4. Okay, so again, you can use Jython as long as what you're customizing your syntax to is Python 2.2. Something very, very similar in the Graal APIs to do the same. Matter of fact, change likely this type, and it'll run almost identically. I've done it, so it's relatively straightforward to do. Okay, let's talk a little bit about some of the syntax of Python. First of all, the obligatory Python hello world. As you can see, the hash here, the pound sign, that is the comment syntax. This is actually some code that I use in some other scenarios, so that's what the begin ends are surrounding. But this here, as with any Unix environment, because I'm running on a Mac, if we have the first commented line or the second or third, as long as there's no non-commented lines, we can specify the interpreter, and then we say hello Python. Now, a couple of things to notice about that. First of all, there's no explicit function called main. That's by choice, by deliberate decision. Python wants to be a scripting language, much like Bash or the command interpreter, etc. And so there's no, execution begins at the top of the file. There is no agreed upon convention for which function is the entry point of the application. Second thing, you notice we declare this variable called message, but you notice we don't give it a type. This is where Python gets the reputation of being a dynamically or weakly or untyped language. There are still types running around here. This is definitely a string type. This is an object. We can call methods on that object, etc. But message, the variable itself, is untyped in the sense that we can assign other things to it. Now, you'll notice that VS Code here is popping up and saying, hey, message is of type str. That's of type string. It's because it's inferring that based on running this behind the scenes. This is what a lot of your Python IDEs will do, is they'll execute the code on the fly to figure out what this type is. And so it's a string, and we could do various string things with it, such as printing it using this top-level function, which is another interesting aspect of Python, in that there are top-level functions, something that we don't have in Java. Well, I mean, technically we have static functions, static methods, but practically speaking, and unless you're very liberal with your import static in Java, top-level functions you should think of as in much the same way that we think of static methods. And the key thing is that there are a number of built-ins that are available to just about every Python interpreter, such as the ability to print to console using just the straight-up function print. Now, to run this, let's go back one. If we are running using the standard Python interpreter, generally it will be Python for Python 2 or Python 3 for Python 3. The naming convention here is pretty deliberate, because a lot of Python developers, if you get too far into the ecosystem, you will end up likely wanting to have both 2 and 3 installed on your machine. Eventually 2 will go away. It's been officially deprecated. It's been officially deprecated for 10 years. But slowly all of the things are moving over. And again, this is why the various powers that be in the Python world are telling you, do all your greenfield in 3 so we don't have to worry about any more backwards compatibility. If we do hello world Py like so, the other thing is, again, if you're on a Unix system, you should be able to do this if you have the shebang syntax. Oh, assuming you have also made the file executable. Oh, okay. So it's not picking up. Again, because this needs to be up here. Now it should work. Oh, it's trying to execute. It turns out my Python interpreter isn't at this file system path. It frequently will. If you install a Linux or a Mac OS distribution, this is usually where Python will be declared, but I'm not going to mess around with it. That's about Unix. That's not about Python. Let's move on to the next. Let's talk about some Python basics. Now, again, you can see that we declare some variables. You can see that we use the underscore. You also notice that most of the time these are lowercase. That's basically Python convention. There are some cases where the Python interpreter will make some assumptions based on what the variable looks like. We'll see this more when we talk about classes down the road. But generally speaking, Python convention says you should always have your variables, your locals in particular, be lowercase. If you want to separate the words, you use the underscore. Notice also that there's this syntax here, x comma y equals 0 comma 0. Tuples are a big part of the Python environment. And this is one of the things that as a Java developer you can benefit from, is seeing how other languages approach to features that Java has not had for quite some time. Now, there has been some discussion about introducing tuples as a feature into the Java language. To be honest with you, I've kind of stopped paying attention to all of the various things that Brian Getz and company are releasing, especially since they went to the 6-month cadence. So I don't know if this has actually made it into the Java language yet, but if it does, you will have some practice working with it if you've been playing around in Python. There are other languages that do tuples too, don't get me wrong. Now, one of the things that you will see is that none of these had to be declared ahead of time. Well, I mean, technically what we're doing is we are declaring and initializing them in the same moment. When you introduce a variable for the first time in Python, you actually initialize it. And if we were to, in fact, just have, you can see VS Code is already barking at me, this is an undefined variable, right? Now, you could argue that, well, I'm declaring that I'm about to use it. Yeah, but if you want to do that, then you've got to give it an initial value. Python will not declare the whole thing to be null just by default. So any variable that's not used before it's declared, or not declared before it's used, that is to say it's not initialized before it's used, will generate a Python error. Now, you'll notice I'm doing all of this in VS Code. There are a number of Python IDEs out there. For example, JetBrains has one, PyCharm, in both a community and a professional edition. If you really, really like your IntelliJ, your IDEA, then I would certainly recommend you take a look at PyCharm and take a look at PyCharm Pro. Again, differences here are going to be the same as between IDEA Community and IDEA Ultimate. There are a number of other tools, including what are referred to as Jupyter notebooks, Jupyter like the planet, but with a Y instead of an I. Those are very popular amongst the data science crowd. If you're running on Windows and you happen to have Visual Studio installed, as I frequently do, there is an Anaconda distribution of Python that ships with the Spider with a Y instead of an I, IDE, and very, very similar in many respects. But a lot of people are using Code. Code has a very strong Python integration, as you saw, just picking up off of the extension. And so it's what I find useful for all of the lightweight Python work that I do. Let's keep going. Tuples. I mentioned we have tuples. Here I'm initializing a tuple, right? Ted Neward 46. This is a proper tuple. Up here, technically what we're doing is we're initializing two separate variables using that tuple style syntax. So 0 is assigned to X and 0 is assigned to Y. This is a more proper tuple, where these three values are now essentially part of an object that is pointed to by Ted. You notice that it comes up with the type tuple. And when I print it, it's going to print out Ted Neward 46 in this parentheses. Here we see Charlotte. This is another way to define a tuple using the parentheses. I personally find the parens to be a little bit easier to read. It's also a little bit easier. The interpreter can help you a little bit, because if you accidentally do something like this, that's a tuple when you meant to do this, meaning I want to initialize two different variables. And if you ever want to break a tuple up, you'll notice that first and last and age can be assigned to the tuple, and this is often referred to as destructuring. The first element of the tuple will go to first, the second element will go to last, the third element will go to age. If there are more variables here than elements in the tuple, they'll basically be null. If there are more elements in the tuple than there are variables here, they'll just be not assigned anywhere. It'll be left on the floor. Now, Ted still exists as an object. We can still print Ted down here. So destructuring here means we're copying elements out of that. We have numerics. One of the nice things about Python is we have the exponentiation operator here. So we have numbers, and there are various flavors of numbers in the Python type hierarchy, integral, floating point, etc. The key thing is to notice that here, when I divide these two integers, I automatically get a floating point. If I want purely integral math, I use the double slash, right? This is part of the reason why mathematicians prefer Python, because it actually is a little bit easier to work with for mathematics kinds of scenarios. Strings, notice we can use both the double quote and the single quote. We can also use R here to indicate that we want to do a raw string, which means that, in fact, the backslash here, which normally would be interpreted as an escape sequence, will no longer be. So this is how we will get this actual raw string to long live metal. Now, the other thing we can do is what's known as string interpolation or string formatting. So here we put an F at the front of the string as a prefix. And now we will go ahead and grab hello and concatenate it into here, as well as string 3 will get concatenated into here. So this is an easy way to assemble strings. It's very similar to string.format, if you're familiar with that from the Java API. Lastly, we have what's known as a here doc string. The triple quotes essentially mean capture everything exactly as is, including new lines, all the way up until we get the last triple quotes. Okay. We can also concatenate strings by simply having strings next to one another. There's nothing in between these, so this is implicitly concatenating these strings. And notice here that SonarLint is giving us a message here saying, hey, this is potentially a problem. Did you want these to be separate string elements in a list, or did you in fact want this to be one string? And so it's suggesting that we actually merge this into one string, which kind of makes sense, particularly because the way this will be printed out, this will be one run-on sentence with no spaces in between, which is probably not what we wanted. We can also take slices from within the string. The string is implicitly array. So here we're taking string 4, and we are grabbing from the 6th character to the 8th character, and that gives us is, right? That's just, it's useful. If we give these negative indices, by the way, instead of starting from the left, we'll start from the right. Don't worry about this class. We'll get to it in a second. The key thing to understand is that we can reference them using the same dot notation that we're familiar with, right? So here the username, here the user age, and we can format it in particular ways if we choose to format it, where we in fact use this placeholder to mean this object. It's not a common use of Python that I find, but it is good to be able to read that and know what's going on when they do the string format. Lists are a built-in type inside of Python. Lists, comma separated inside of square brackets. Yes, that does mean that square brackets refer to a list, a singly linked list, as opposed to an array. It is by design. Python actually prefers lists over arrays. Considering arrays in C were originally about doing in-memory access, yeah. We can access them using, again, the array subscript style syntax from Java. Again, negative starts from the end of the array. Notice that arrays are implicitly polymorphic. Oh, that's right, we're in a dynamic language. Never mind. We can also concatenate lists using the plus. This will concatenate these two lists and form a third list. This is actually fairly efficient. It's not doing a copy of, so list 1 and list 2 continue to point to what they originally pointed to, and list 3 will now point to a concatenation of the two. We also have sets. Sets, as you remember from your mathematics class, are collections of unique items, which is why Visual Studio Code is giving me grief, because I'm deliberately introducing duplicates into this set. We also have basic math over each of the sets. The and, let's see, I'm trying to remember. This is an and, this is an exclusive or, this is an or. I don't remember exactly if that's correct. I don't do a hell of a lot with sets, particularly not the set operators, so this is not top of mind. But again, the Python tutorial will have extensive documentation around all of this. We also have maps, dictionaries. These are basically key value pairs. The key can be anything, the value can be anything. Here I'm just using it as strings. Notice we use the curly bracketed syntax to do this style of in-place initialization. You can also use array style syntax to assign to a particular key. We can get a hold of the keys, the values, or the items, which are a collection of tuples. Okay. We can also initialize the dictionary like so, right? Here where we put the key and the value, comma, the key and the value. There are some folks who are a little split over to whether this makes sense or this style makes sense. Fundamentally, under the hood, it's just a dictionary. Don't worry about it. Functions. Python has functions. Remember, I talked about functions can be defined at the top level. One of the interesting things about the Python environment, let me drop over here and drop into a Python 3 environment. Pull this up a little bit so we can see it. One of the things about Python being a dynamic environment is the fact that we can actually ask it at runtime to give us a list of various things. So here, if I say hello Python, like so, I want to find out what is available, like what is available to me inside of this environment. Now, that is generally a built-ins construct. So I can do this. The double underscore, by the way, is syntax convention that Python reserves for interpreter and or for its own use. So generally speaking, you want to avoid the double underscore syntax. This will give us a list of all of the built-ins. Now, these are both classes and functions because, frankly, Python doesn't see a distinction. They're both basically objects. But you can see that we have a collection of functions here: absolute, all, any, ASCII, bin, bool, etc. These are functions that do a variety of things that the powers that be inside of the Python environment determined would be useful. One of the things, for example, we see is the double underscore doc. This is generally used to provide documentation to a function. So if I say here, print dot underscore doc, what we get back is a string. This is literally the Java doc, well, the PyDoc, for the print function in which it describes itself. And you can do this for any given function, as we'll see when we start getting into the definition of functions. Now, I could actually, well, let's see, we could do dir dot, and this gives a list of strings, return the names in the current scope. And these are the names that are in the current scope. Annotations, built-ins, and that's why we have the built-ins, where I was able to reference it. So this is one of the powerful things about Python, is the ability to just fire up a REPL and start experimenting with some of this stuff. So for example, if I want to grab this, pop it in, notice I just pasted directly in. The dot, dot, dot is because it interpreted the carriage return and said, oh, you're still going. Notice the significant white space here, right? That is actually how Python will determine scope. So that now when I hit the carriage return, I can say howdy, oops, like so, right? So notice it returned. We see the return value here as well as the fact that it printed. And if I say howdy, well, yeah, it doesn't really tell me anything. What it does is it comes back to something else, right? So what it's doing here is it knows that doc is a string, and so therefore it gives us some information about string. That's not exactly what I wanted, right? So let's see here. Now you see that we're printing out the doc. Occasionally, the interpreter will give you things that you weren't expecting. Specifically, what came back was a string, which then the interpreter said, oh, this string, it's a type. Let me go ahead and print that out. Here, if I want to actually see what the doc was, I have to print the resulting doc string. But notice that it, in fact, captured this first here doc string as the value of double underscore doc. And so by convention, you put, just like in Java, you Java doc every function you create. Here in Python, you document every function you create. Now, the rest of the syntax is pretty straightforward. Def indicates we're defining a function. This is the name of the function. The parens are where the parameters will go. The parameters, remember, dynamic, untyped language. We don't need to specify the types. We specify here the name of the parameter, but we can also specify an implicit value, like so. We can also put a variety of them, right? So we can have an arity, a multiple arity, and in this case, all three of these have a default. Now, in some cases, people calling this function may in fact want to call it in a slightly different order than the way it was defined, in which case we can do what are known as keyword arguments, where we specify the argument that we're supplying with its value. So even though message comes first, we can specify we want the message to be last. And, you know, particularly if you're a closet Objective-C programmer, and you really like putting the method names in your call, you can do this. And a lot of Python IDEs will help supply this information in terms of a IntelliSense. We can also do variable arity calls. So here, this is a prefix, and then the star indicates that this is a list containing the rest of the arguments. So here we see it calling with one, calling with another. Very similar to the rest and spread operators from JavaScript. Here, args is simply just like arguments from JavaScript. It is simply a list of all of the arguments, regardless of what you call it with, as well as their names. So here, when I speak these, I'm getting a dictionary of all of this. We can also use functions as literals, which is something that Java has given us. Thank you very much. So here I define a function called capit that actually takes the passed in value and calls upper on it. Now I'm assuming it's a string. And so here, when I do hello, guten morgen, bonjour, when I say print capit hello, I can also use capit to map over the collection that's in messages. This is where a lot of people say that Python is a functional programming language. I'm not entirely convinced because we don't have a lot of the other values of a functional language, such as immutability by default. We don't have the ability to query explicitly, etc. We have functions as first-class values. We can define anonymous functions, right, using the lambda keyword. So here we're creating an anonymous function that takes one parameter x. And notice that I can assign the result of this lambda to this variable here and then invoke it. Right, I can call add one, right, and it will behave just as if I had done a def on it. We do see a lot of that kinds of stuff inside of Python. Now, Python also has generators and comprehensions. If you're familiar with these from JavaScript or some other functional languages, you'll understand how they work, that essentially we can call in here, yield a result, and come back and call in from where we left off, which makes Fibonacci very, very easy to build. Comprehensions are essentially mapping over a range and providing some values. And again, this is where a lot of Python gets its reputation as a functional language. One of the other thing, though, that we run into is as part of Python 3, they wanted to try to make it a little bit more explicit as to when you're referencing a global as opposed to a local. So one of the things they introduced was in Python 3 was the global keyword. If we have this do something method that references the global variable player here, without declaring that we use that global, it will essentially say, oh, well, this is a local and go from there. And then because we're using local variable player referenced before assignment is the error that will come up. Because notice we're using it as part of the definition here. So to make this work, we have to uncomment out this, at which point now it will do what we think was intended, which is to say we want this string to say Fred and Jack. Okay. So global is only going to be something that's necessary if you in fact reference global variables. But if you don't reference globals, which of course most people will tell you not to because globals are bad, singletons, however, perfectly acceptable. You won't run across the global keyword very often. I mentioned classes, mentioned that this is an object-oriented language. Yep, we can use class and notice the uppercase P. Classes should be leading case capped. So class person should begin with a P. Notice the here doc string serves exactly the same purpose. Person dot double underscore doc will give us the description for this person type. Notice the introduction of a variable here. This is actually a class variable. This is a static. This will be defined on the person class object. And I use that terminology deliberately. At runtime, there will be an object that represents person, that when we instantiate a new person, it will prototype clone this person class object. It will effectively execute this class definition to build the instance in question. So these are essentially class variables because they're defined on the person class. And we reference them the same way as we would statics in Java. So we have a static method called say hello. Now, if I want instance variables on a person, I do so by defining a constructor. Remember, the double underscore indicates it has special meaning to the runtime. And in this particular case, this, the initializer, is what's used as a constructor. You'll see that the first parameter here is self. This is your this. You can call it anything you want. By convention, we call it self. FNLNA for first name, last name, age, and we assign, remember that whole concept about we assign at the time we introduce a new variable? Same thing happens inside of a class. Python wants to hang together in a very tight mental model. So if that's how we do local variables, then this is how we do it for classes. So here, self.firstname, self.lastname, self.age, and we're off and running. when we want to define a method that operates off of the instance, notice that we explicitly pass in the self so that we have the instance that we work with. You're either going to love this or hate this. Personally, I like it just because it makes it more explicit which are static, no self, and which are instance, we have a self. But a number of folks that I've talked to find this to be kind of awkward, and why can't just self be implicit? Why can't it, and then we use a keyword out here for static. Look, at the end of the day, you're going to have to mark somehow whether it's static or instance. This, I think, makes more sense, particularly because it makes it easier to understand that at runtime, when we instantiate one of these persons, we're actually playing out the definition inside this class when we instantiate it. So here we see instantiating a person. Notice we don't use a new keyword. We just say person, and then we can call code on it. Now, monster here, we initialize. Notice that we can also provide some properties, get name, set name, and del name. Python considers a property to have all three of these. And there is, in fact, a metaprogrammatic function that defines these as a property. In other words, we are going to define a property by the name here, because otherwise I would just go and say person.firstname, and I'm accessing the field directly. I don't like that. We like properties. We like being able to do a point of control as somebody is accessing this. So we can define a property, get name, set name, del name, and this is the here doc description for that property. And now we can just go ahead and reference orc.name, which will call into get name, which will return self._name. Okay. Now we can also do this using a decorator. This is another function. Well, technically it's the same function. It's really keyed off of how we're using it to create name as the property. Notice that we can also specify the setter is this and the deleter is this. So again, there's some flexibility in terms of how you actually define your code in Python. If you leave out a setter, leave out a deleter, it becomes a read-only property. To do inheritance, we simply specify the class we inherit from in the parentheses here after the class name. So here, when we study, we are saying that, we are inheriting from person, so we know we have a first name, is studying this particular subject. Okay. Now, again, dir works on classes. It works on instances, so we can see what's present on intern. Because again, when we get into some of the metaprogrammatic features, we can actually manipulate the definition of these objects. We can change the members and methods, functions at runtime. That's not always something that's a good thing, but it's a very, very powerful thing. Notice also that we can reference, again, functions are first class values. And so here I can grab the code function off of the intern object and call it, and it will actually capture the self as a part of that, so that now when I call this, Joe intern is the one that's coding. So that self is in fact pointing to something. Some additional conventions, if we want to do any sort of operator overloading, __ named methods. So the equality functionality, the equals method from Java, is represented by __ EQ. There's also a less than or equal to, greater than or equal to, or not equal to. Generally, if you do an equals, you should do a not equals. And frankly, if you're going to do something that has any sort of ordinal concept to it, you should also do the other mathematical operators, but that depends on the type. And notice here, person.list languages. Wait, go back up to person here for a second. I don't have a person.list languages. Again, dynamic language, metaprogrammatic language. We can actually manipulate this at runtime. So here I can add a new, basically a new class function, because this is on person itself, saying there is only Python. And I can also create an instance method by adding a lambda that takes a self and saying so-and-so is coding in Python. This is a taste of some of the metaprogrammatic features of Python, which let's dive into real quick here, right? So now here we have a fake number that has an add on it, which will just basically add whatever is passed in, right? We can also do some interesting metaprogrammatic stuff by taking functions as first-class values and sticking them into a dictionary. Syntax is a little awkward. We can do this in Java, by the way. You can take you can take a runnable, for example, and make that the value of a key inside of a map, as long as the map is typed correctly. Unfortunately, implicit typing coming in some future version of Java, or I think maybe it's shipped as part of 16, or maybe it's coming in 17, I don't remember. But now we can say var x equals in Java. Yeah, same kind of thing here. We can say speak, the key is associated to this lambda, and print it out, right? Now, the self manipulation gets a little bit weird here because we're capturing the person as a part of this, but we're doing this inside of the person instance anyway. So this would kind of make some level of sense. Still, it's kind of awkward. Now, if we wanted to create our own decorator, in other words, we want to be able to do something to this function. So here we've got this function say whee, but we only want to execute it between the hours of 7 and 10, 7 a.m. and 10 p.m., or 0700 and 2200 for those of you from the military or from Europe. Well, we can define this as a function, right? And notice the function comes as a parameter. Now we actually can define a wrapper that tests whether or not we are in the right time. Notice this is args and this is keyword args. This is another way of capturing what was passed into the function. And here we're just going to pass them straight through, but you do have the ability to manipulate the args and to manipulate the keyword args if you wanted to change what was coming in, or take the return value and manipulate it in some way. For those of you who are thinking this sounds a lot like aspect-oriented programming, yeah, because AOP in Java builds itself very, very strongly around the concept of method interception. Now, if you're using AspectJ, where you can do actual point cut weaving and manipulate, including things like variables and so forth, that's a whole different ballgame. But for a lot of the early AOP libraries in Java, to do this kind of method interception required a tremendous amount of work. Python has it out of the box. It's because everything is evaluated at runtime that we can now use this decorator, and this will only execute between the hours of 7 and 10. We can do the same if we want to capture timer, right? So here we can calculate how long it will take this particular function to run and print that out. And when we decide that we don't want to time that thing anymore, comment it out. This is really just the beginning of some of the things we can do with Python, because we can actually get a hold of any particular object that, we can get a hold of the class object for any particular object by calling the _ class member. I'm going to use that very generic term because whether it's an object, whether it's a function, kind of sort of doesn't matter at a certain level. We're going to get a hold of this, or we can use the type function, which basically is a way of calling this. Type is a little bit more, it's a little bit more portable. The Python folks would prefer that you use that, because if they ever, for whatever reason, needed to change this convention, this will continue to work where this may not. But the chances of them changing that are pretty few and far between. But wait, there's more, because we can also use type to define a new type. So here we are creating a class at runtime called rfoo. Not, he's R2's younger brother, not quite as smart. And rfoo here is basically empty. He's just like foo up here, right? But now we can actually do a couple of things with it. We can define rbar, which inherits from rfoo. This first list here will be a list of all of the classes that we want to inherit from, classes or interfaces, like so. Right? You can see Visual Studio Code popping up and saying, what's the name? What are the bases? And then it's asking for a dictionary. This dictionary here will be a list of all of the members of rbar to start. So these will be basically your class members, your statics. So here, rbar, given the fact that it's a bar, it's a very nice bar because it has 100 different scotches, which, by the way, I'm very jealous, because one of the things I love to do when I'm over in the UK is consume scotch. So here we can instantiate an rbar, and we can see the object scotches show up. We can print out the class. We can print out the bases for the class. We could define my person type here like so, and then use it just as if I had done back in the classes the classes demo, right? So here, first Ted, last Neward, speak, etc. There's the lambda and so forth. We can also have a new function that creates a new, I mean, you know, there is a lot. I'm just, again, scraping at the top here where we are defining a new. And so when I call foo _new, when I new up a foo, what I get is a random attribute. So literally I can hook into the allocation of a new object to provide a new random attribute, regardless of how it's allocated up. And then we can start working with meta classes, which means we can actually get a hold of the new that's used on this class. And you begin to see that there really is meta going all the way down. I can hook just about anything inside of the Python interpreter. Now, if you work in an environment, if you work in an interpreter that is not based very heavily on C Python, right? It should, all of this is standard Python. It should be supported. Oops, sorry about that. It should be supported, but again, different interpreters may have different degrees of compatibility with C Python. A lot of this stuff that I'm showing you here in the metaprogrammatic section, this is what Guido wanted to clean up for Python 3. So a lot of this will not work for Python 2. That will be the biggest drawback to using Jython, is you may not be able to use some of this metaprogrammatic functionality. But if you're interested in doing some of the basics, the flow control here, you can see if we significantly indent, notice the colon, all of this syntax will be very straightforward for Java developers to pick up and use. All of this is something that would be possible, usable from inside of Python 2. The syntax hasn't changed that much. It's really only the metaprogrammatic stuff that we see in Python 3. I'm out of time, which sucks because there's just so many interesting things about the Python environment. Didn't even get into the ecosystem, didn't even get into all of the various packages that are available. Didn't really talk about some of the ways in which we could use Python and Jython and Graal to create sort of a polyglot environment. I will leave that to others. I know that there are a number of people there who will be able to talk to metaprogrammatic capabilities. What I wanted to do was give you the basics of Python, give you some idea of why Python would be interesting and how it could work, as well as show you, to some degree, how you can make Python and Java interact. With that, I'm going to sign off, again, from lovely, gray, overcast Seattle. Hopefully it's not too much more grayer or overcaster out there in the UK. And to all of you speakers who I weren't able to hoist a scotch with this year, cheers, mate. Next year. I'll see you next year. Take care, folks. My name is Ted Neward, and this has been the Busy Java Developer's Guide to Python.